This section of our site is on quantum numbers. Now, quantum numbers are the numbers that describe every electron's location in an atom, and there are 4 of them. Now, this description is necessary because of the Pauli exclusion principle that essentially states that no 2 electrons in an atom can be in the same type of electron probability cloud with the same spin being a property that I'm going to talk about in a minute, at the same time. So every single electron in an atom has to be differentiated by these numbers. Now, the different quantum numbers are the principal quantum number, n, the angular or azimuth quantum number, L, the magnetic quantum number, m or ml, and the spin quantum number, s or ms. The first quantum number that we're going to talk about is the principal quantum number. This quantum number describes the size and energy level of an electron in an orbital of an atom. So it also represents the shell that any given electron is in, as you can see in the picture. N is the shell. This quantum number's value is always a natural number, which is, it is always greater than or equal to 1. The next quantum number is the angular quantum number. The angular quantum number essentially describes the shape of an electron's orbital. It can have a value greater than or equal to 0 and less than or equal to n minus 1, depending on this value. The suborbital for the electron is changed, as well as the shape of that suborbital. And different suborbitals have different numbers of probability clouds for where electrons can be placed, and this steadily increases along with the value of L. Since every probability cloud contains only 2 electrons, one with each spin, the spin we'll talk about in a minute again, and that accounts for the increasing number of electrons that progressive orbitals can hold, as we learned as a class. Now, here I go into a little description of that. The s suborbital occurs when you have 0 as your L value, and the shape that will be produced for the orbital is a sphere. With the p suborbital, the number for L is 1. The shape you'll get is polar. For the d suborbital, the number you're going to have is 2, and the shape is a cloverleaf. And F, the F suborbital, the number is 3, and the shape is complex, but it's similar to a more complicated cloverleaf. Now, more on those electron configurations and how quantum numbers relate to that can be found in the quantum numbers and electron configuration section. The next quantum number is the magnetic quantum number, and this describes the orientation in space of any given orbital of an electron. So the value of the magnetic quantum number is greater than or equal to negative L and less than or equal to positive L. The magnetic quantum number determines the probability clouds that a particular value of L can have. A different value for M, in effect, changes the shape of the probability cloud that an electron can occupy. And you'll see more about those probability clouds in quantum numbers in electron configuration. The final quantum number is the spin quantum number, and it's the easiest to explain. Although electrons don't actually spin in their orbitals are just kind of probabilistic zones of where they're most likely to be at any given time. They behave as if they were spinning. They're not actually spinning, but they have a spin behavior. So, since there are only 2 ways something can spin, clockwise and counterclockwise, there are only 2 possibilities for the spin quantum number. And that's the positive and negative value. The positive value being 1/2, the negative value being negative 1/2. Scientists deduced all this information, originally starting through experimentation on the atomic model, and eventually trying to achieve theories such as the Pauli principle, which was eventually achieved after Pauli discovered the spin quantum number, the final quantum number, to try to explain an electron's place in the atomic model. Originally, Bohr theorized quantum numbers by accident when working on his planetary model, which was eventually proven incorrect, but it's developed from there. So N was discovered by Bohr, and it was the first to be discovered. Then Sommerfeld discovered L and M, and finally Pauli himself discovered S. And no, the electrons do not spin around a nucleus just like planets around a sun. They inhabit clouds, as I said before. Bohr's planetary atomic model theorized exactly that they spun around the nucleus like the planets spin around the sun, and that was incorrect. So that just about sums up quantum numbers, and for quantum numbers and electron configuration, the link's on this page. So that is it.